payment period, so these are terms that you might hear as we go through this. So if something is annually, how many times a year is that? Once. All right, what would semi-annually be? 2 times per year. Quarterly?
4 times.
Monthly? And the one a lot of people somehow don't know, what's daily?
65.
Thank you. Okay. So those are the common, not the only options, but the ones that we will be seeing. When you are paid interest or you are paying interest, it can be calculated any of these ways. We've talked about simple interest before, just principal times rate times time, but that's not usually how it's done. We usually have compounding where you pay interest that gets added into the principal amount, so it's constantly growing. When we calculate this compound interest, we use this formula. I will not require you to memorize the formula, so I will give it to you, but you have to know what the variables stand for. So the formula is given, but not the definitions of each variable. A is your ending amount, sometimes called the future value. P is what you have right now, so that is your principal or the present value, the amount today. R is your interest rate. That always has to be in decimal form. So if I said 15% was my rate, what would I put into my formula? 0.15. N is the number of times we compound yearly, which was what we were talking about over here. And T is our time, but it has to be in years. Okay, so if I tell you my time is 24 months, you wouldn't plug in 24, what would you put in? 2 for 2 years. All right, but daily isn't like the most frequent. We could compound interest every hour or every minute or every second. And as we're doing it more and more often like that, it turns into what's called continuous interest. So if I say interest is compounding continuously, we can't specify how many times a year continuously is, so we have a different formula. A equals PE the RT. Same variables, A, P, R, and T. You'll notice there just isn't an N in this one. E is a button on our calculator. It's kind of like pi. It has a set value. So both of these formulas will be given. All right. So the biggest issue with these is knowing what your numbers are, or what numbers you've been given. So here's what I want on these problems. We're going to figure out which of the 2 formulas we're using. Then we'll make a list of all the variables that we have before we plug into our formula. So if I ask you to find the future value of $100 invested at 4%, compounded quarterly after a period of 13 quarters. The only time I use the second formula is if I say compounding continuously. This isn't continuous, so it's the first formula. So that means my variables are A, P, R, N, and T. So let's see what we have. Find the future value. Which variable is future value? A. So that's what I don't know. Of $100. So what would the 100 represent? The P. That's what we have today, our starting amount. 4%. The percent is my 0.04 for my rate. Compounded quarterly. So my number of times per quarter is, or per year, quarterly means 4 times per year, so that's my N. Remember, N is the number of times per year. After a period of 13 quarters. Okay, that's my time, but time has to be in years. How'd you get it? You divide it by 4. So my time is 3.25 years. All right, now we plug in. We don't know A. P is 100. R is 0.04. N is 4. The N, so 4 times 3.25. All right, at this point, we just need to plug in. I would recommend typing this whole thing in at once. So just 100 parentheses, type it exactly as it's written. 1 plus 0.04 divided by 4. I want everybody to plug this in so that if you don't get the right answer, we can look at your calculator and figure out why. A is our ending amount. That is a dollar amount, so we're going to round to 2 decimal places. So it's 113.809, so that would be $113.81. All right. Does anyone need to look at their calculator right now? Okay. Yeah, parentheses make a difference. All right, this one asked me 2 questions. That's part A, the future value. Part B asks me, how much interest have I earned? I currently have $113.81. I started with $100. So to get the interest, the amount you were paid, you just take your ending amount minus your starting amount. Okay, so we can see we were paid $13.81 interest. All right. Questions right there. Look at some more. Leah must pay a lump sum of $15,000. What amount deposited today at 4.8% compounded annually? So it's not continuous, so that means I'm using the same formula. So we have all of these variables we need to find. Okay, so what amount deposited today? Well, I'm asked to find the amount today. Which variable is the amount right now? P. So P is what we don't know. 4.8% would be 0.048. Which variable does that go for? The rate, the R, 0.048. Compounded annually. Annually is how many times per year? Once. Which variable is that? N. Will give us $15,000. So that's what we end with. Which variable is what we end with? In 42 months. That's giving me my time, but it has to be in years. So we have to divide by the 12 months in a year. So now we plug in. So my A is 15,000. P, 1 plus my R, 0.048, divided by N, which is just 1, to the 1 times 3.5 power. I want to get P by itself. P is multiplied with this. What's the opposite of multiplying? Dividing. So to find my P, I have to do 15,000 divided by this whole thing. You're welcome to plug in this whole thing as it's written. If you want to simplify some stuff, you certainly can. Like 0.048 divided by 1 is just 0.048. 1 times 3.5 is 3.5. But I usually don't simplify much. I usually just type it in. P is, again, the principal, the dollar amount. So we should get $12,729.09. Does anyone need me to look at your calculator? Part B. If only $10,000 is available to deposit right now. So we're still looking at this. If I have 10,000 right now, which variable is what we have right now? What annual interest rate? So if it's annual, how many times are we compounding per year? I'm looking for my rate, so R is my question mark. Is necessary for the money to increase to $15,000 is what I want to end with, so that's still my A, in 4 years. So the time is 4. All right. So plug in. A is 15,000. P is 10,000. 1 plus, I don't know R, N is 1, to the 1 times 4 power. Right, I have to solve this thing for R, so we do have to get R by itself. What would we do first? Okay. So how about, let's move this 10,000 first. We could multiply by 1 over 10,000 or just divide by 10,000. You get 1.5 equals 1 plus R divided by 1 is just R. 1 times 4 is 4. How do we get rid of a 4th power? We would the 4th root, right? Typically with an even root we do plus or minus, but an interest rate can't be negative, so we don't have to worry about that. So then to get R by itself, we subtract our 1. So I have the 4th root of 1.5 minus 1. This is the interest rate, so it's R. Don't round to just 2 decimals, keep a few more. So if I keep 4, 0.1067, or you could say 10.67%. So we don't have to just solve for the same variable every time in these. I could ask you to solve for any of them at this point. All right. Is that one okay with everyone? I am going to skip the next slide. I'm going to go to this one. Find what investing $1,000 at an annual rate of 10% compounded continuously. When you see that word continuously, what does that mean? We use the continuous compounding formula. So that means I have fewer variables. We need A, P, R, and T. Investing $1,000, so that's our starting amount. Which variable does that go in for? P. At a rate of 10%, so my R would be 0.1. Compounded continuously for 2.5 years, so that's my time. And we're trying to find what we would get, so we're looking for A. So we have 1,000 e to the 0.1 times 2.5 power. There is an E button on your calculator. It's second then the natural log, the LN button. So if you're using the graphing calculators, it's on the left-hand side, like 2 buttons above the on. So we should get $1,284.03. So A is always bigger than P. You should always end with more than you start with when you're earning interest. If I asked you how much interest had been earned, right, $284.03. You would just subtract the 1,000 that we started with. All right, does anyone need help with their calculator? Let's look at a few more. All right, so on this one, I see the compounded monthly, so it tells me that's not continuously. So we're using the first formula. So those are the variables we need to figure out. Find the present value. Present value is which variable? P. So we're looking for P. Of $100. So 100 is what we have right now. So that is, sorry, 100 is what we are going to end with. So that is my A. After 2 years, so 2 would be my T. 6%, so R is 0.06. Compounded monthly, so N would be so I'm plugging these things into my formula. All right, how would I get P by itself? 100 divided by this whole thing. You're welcome to simplify it more if you want. I usually just go straight to my calculator and put it all in. What'd you guys get? $88.7185, so we round that to 72 cents. So $88.72 is what we have to start with. How are we feeling about these overall? Pretty good? I have 3 more examples. We'll do at least one of them, but if we need the others, we'll do those too. What annual rate of interest, compounded semi-annually? When I see semi-annually, which formula am I using? The first one. When's the only time I use the second one?
Continuous.
What rate of interest? So I'm looking for my R. Compounded semi-annually. What does that tell me? 2. For which variable? N. Should you seek if you want to double your investment in 5 years? So T is 5. Okay. I did not give you very much information. Did I tell you how much you're starting with? No. Okay. Let's pick a number. How much money do you want to start with? $1,000. Okay. If that's my P. I didn't tell you what we were starting with or ending with, but what I did tell you is I want you to double it. So if I start with 1,000, what do I end with? If I told you you were going to triple it, what would you end with? 3,000. Okay. So now we can plug in. A is 2,000. B is 1,000. Plus R over 2. 2 times 5 power. All right, if I'm solving for R, how do I get rid of my 1,000? So we get 2 equals 1 plus R over 2 to the 10th. How do I get rid of a 10th power? 10th root. You could put that in your calculator, but it's just going to be an ugly decimal, so I'm just going to wait for a minute. What would you do next? Subtract 1. And final step to get R by itself? So I take this whole thing times 2. That's what I'm going to plug in. 2 parentheses, 10th root of 2 minus 1. So we get 0.1435 or 14.35%. Any questions there? Why don't you guys try the very last example? So we'll skip the next one. Go to the very last one, see if we can set this up and be done for today. So we see this word continuous, which means I'm using A equals PE to the RT. So there's no N that we have to find. Find the amount in an account. If $2,000 is invested, if that's what I'm investing, that's what I'm starting with. At 8.5%, so what's my rate? Right, you always have to think, divide it by 100 or move the decimal back 2. Compounded continuously after 2 1/4 years. So 1/4 is 0.25, so that's 2.25 years. So we're looking for A. We have 2,000 E 0.085 times 2.25 power. And we get
2,421.
good. What if I asked you how much interest you had earned? Right, you just subtract the amount you started with. Okay, any questions? There is a handout posted on Classroom. Be careful, the first two questions, I think, do ask you to find your ending amount and the amount of interest that you earned, so make sure you answer both parts of the question. But you have quite a bit of time right now to work and ask questions, check your answers.